working with. So one way we can use threading is to take one process and run it in the background, so to speak. And it just keeps running until we stop it. We don't have multiple processes stopping and starting. We have one that we start, one that we stop. And sometimes that's what you want to do. For example, if you have a robot and you want to have it, do an ultrasonic scanning thing, and you still want remote control and you want to have sensors running, each of those would be a separate background task. And this is very similar to what Jess is working on with her NASA project. We can start the thread. This is just a little timer, counting. And then we stop the thread.
Toggle it.
Yeah, so that may be what you want to do. You want to run one process, and maybe you want the process just to keep going. Like in my ISS one, I started out, everything runs this little process. I want it all to keep going until I exit the program, so I don't have a stop and start. But it's a single process I want to keep going. Well, in this case, we have 254 IP addresses on a typical network, right? So we're going to have 254 little processes we have to stop and start. And we don't want them running into each other. We don't want them all printing at the same time. We want them to all take their turns. So we have to introduce a couple new things. Queue. This keeps track of the threads. So for example, you go to the post office and there's 10 people in the queue. You take your place at the end. As soon as the first one is finished, they go out and they come back to the end again. Or you have a new person come in. So that's what a queue is like. So far, so good. We are going to do threading, but we only want one thread to finish at once. If we don't do, we want one thread to finish at a time. If we have all the threads finished willy-nilly, we could have 3 threads finishing at the exact same time, which would mean we have printing that goes across and not where it's supposed to do. So we want to define a lock so they don't run into each other, which is not bad. It's just when we're printing, it ends up being a mess. We're going to start out with 5 threads. We've done this. We're just doing a little counter here. I don't know why I did R. R in range, I guess. So this is going to quickly spawn 5 separate threads. This is the method that we're going to talk to. They're all going to be daemon threads so that no matter what goes wrong, when the program ends, they're all taken care of. Then we start each thread. Well, before we send them to the queue, we're actually creating tasks here. Before we send them to the queue, we're going to start a timer, which is just keeping track of the time elapsed. So far, so good. Then we put them in our queue. If you ever watched Star Trek, you know who Q is.
Mm-hmm.
And you know who Q is. Q is John.
Specifically, you have to watch Next Generation.
Most. So for each item, why do I have 10 here and I have 5 up here? Okay, so that doesn't make sense. That should be 5, shouldn't it? Because I'm putting my 5. No, tasks are separate. Okay, sorry, I haven't looked at this. So we have 5 threads. We're going to create 5 tasks and put it in the queue. So that means we have 5 workers who are going to do 10 things, like we're building a house. The first worker has to get out the nails. The second worker has to get out the hammers. The third worker has to start pounding nails. And as the 5th worker comes by, well, then the first worker goes back to the beginning and he does that one. So we're going to go through all this until the queue is done. Join lets us stop. Our main thread of the program waits until they're completed. And then this gives all the time. So the worker method gets the next task in the queue. And this is my work. I'm sleeping for 1 second. I lock that particular thread that we're working with right now and print it out, and then I go to the next one. So they may finish exactly at the same time, but they're not both going to be in the queue at the same time because my queue is 1 through 10. Does that sound accurate, Mike?
Yeah,
More or less analogy?
I don't know.
Oh, is this new or no?
About Q?
Yeah.
I usually don't use Q, but anyway, I understand it.
Okay, so the idea with this is that you can have, like when you're scanning IP addresses,
Mhm.
you're gonna have 254 tasks.
Yeah,
And we don't want everything to print out at the same time, so we have to lock, well, let me go to that one, because then that's the theory of it. Let's look at the threading thingy with our,
yeah.
with this guy and see how that goes together. There it
I
is.
did that thing. I just created the same amount of workers, and at one time it scanned in 1 second everything.
Yep, and I did that too, but what if by doing that, you overload the resources and you only can allocate 50 threads?
Mhm.
Or you want to only allocate 20 threads, because this is a very simple tasks, but that's the idea of being able to reuse the thread and keep going until you're done.
Mhm.
So it's like working on a job site. This is your 10 workers or 20 workers. And what we want to make sure is that none of them finish at the same time. Because the queue manager, which is like the construction manager, he cannot give directions to more than one worker at a time. Right, so he has to give directions to one worker at a time. He's in charge of the queue. Once that worker has finished that job, and we can't have two people finishing at the same time because the construction manager doesn't like that. He's very detail oriented. He can only tell the next person what to do. So when they come up, when they're done, they get to the end of the queue, because if they both finished at the same time, you'd have two people fighting to get in the queue, and that just would not be fun. Because in our case, our work is just printing out that we're done. So I'm going to do 20. So getting the network, well, let's just go to the very end where we're dealing with the threads first. So I'm timing it just by using the time function. How many threads do I have? There's my target. They're thread daemons. We start things. We put all of the hosts into our queue, which is going to be 254. We'll get to how we do that later. And so this is where all the work happens. And until this is done, we don't go to join. What is happening in the worker? The same thing as before. We're getting the first IP address, which would be 10.0.1.1.
Mhm.
And then we scan that. We say, yep, we are done. The task is removed from the queue. Then the second worker comes in and he does his task, and the third worker, because we're in a row. We're doing 1, 2, 3, 4, 5, 6, 7, 8, 9, clear up to 254. We're keeping everybody in order. All right, so now let's look at the task. Our task is,
Scanning.
before we even start doing that, we have to do this one. Before we start our whole thread business, or we start doing any of the threads, we have to get our network addresses, which we get from the user. So in my case, I was doing all my testing at home and I got tired of typing that in. So I set a default local network for me.
Yeah.
And you can set that to whatever. So in an input statement, you can use the OR command. Either you type something in. If you don't type something in, this is used automatically.
Mhm.
This way someone can put in whenever they want, or I can go through and test it. I don't remember, I had to
By
look
the
that
way,
up.
I didn't know that syntax in Python.
I didn't until I looked it up. I just got tired of typing this in. So
Yeah.
how many things in programming are created?
No, I mean this little OR that you can use OR just after input. I didn't know that it's
The only reason I found out is I got tired of typing that in.
Python many years I did.
And I thought, well, there's got to be a way to
But it's
set.
pretty useful. You don't have to do if input is empty, then
Mhm.
do this. It's more concise and
So my
nice.
pondering is, and I'm thinking it's true, how many things in our programming languages are invented because a programmer got tired of doing it that way
Mhm.
and wanted to find a faster way to do it.
Mhm.
I didn't invent something for Python, but I found something I didn't know about. Because I think I probably started out with the if thing and that just didn't work right. And I thought, well, let's see what somebody else has done. And I scavenged the internet and found it. It was pretty cool. Okay, so we have a new library announcement. This library is specifically for converting IP addresses and masks to a list of hosts. Ooh, that's pretty specific, isn't it? But that's what it's for, built into Python. Because IP addresses are actually, what type of data type is this?
It's string.
It's a string. Which, when I was doing this without using IP address, it was like, how do I make this work easily? And it was not working easily. But there is because you want to turn it into a list. You want these 254 addresses turned into a list. And I was working and trying to figure out, well, how do I take this string and turn it into a list of individual numbers? I tried looping and all kinds of stuff. Then I found this library and it does it for you. It takes the network address we've typed in and it gives us a list of hosts, which would be 10.0.1.1, 10.0.1.2, and it goes right on down the way. But it's not a real Python list. It is a list that we can then convert into a list. So this is the host address object. And what this does, and the host address object contains a list of IP4 addresses, but it has other information we don't really need. So we just want the host's information. So in 2 lines of code, I did what I was trying to struggle in several lines of code to do. Find the right library. All right, now we have our list. We're going to start our scan. So here's where we create our threads. Create our little worker guys. They come to work. We're going through all of our hosts, which is a list of strings. Oh, no, it's not a list of strings. It's a list of still IP address objects,
Objects.
but we have to convert it to a string. So it comes out 10.0.1.1 because that's our target. We have to have a target string. So the first guy comes up and says, yeah, I think I can handle this job. Let me get my chaw out so I can make sure I'm ready to go. And he gets the first IP address. He pings it. I'm done. There was nobody home. That's kind of how it works. Here's our scan function. So the scan function is called right here. Our host is an IP address. We ping it. We bring it in as a parameter. Ping that address. We're going to do it twice. We're going to time out in 2 seconds. If nobody's home after 2 pings and after 2 seconds of waiting, they're likely not alive. Is this a guarantee? No. If the host is not set to respond to ping requests, we'll never find it. If the result, which is part of our ping library, is success, we track with our running total how many live hosts we have. Then we print out that, oh, here's our average milliseconds, and you can get all kinds of information out of this library. And if there wasn't a success, nothing happens. So let's see what happens. Oh, what did I do wrong there?
/24.
There, I defined a single address
Uh-huh.
and it scanned it just fine. Didn't even need threads for that, did I? I want my network address. Okay, Mike, what did I do wrong there? Did I do my slash the wrong way around?
3 hosts found. It says 3 hosts found.
Pause while we figure out what the heck's going on. You were emailing somebody that does like huge gigantic stuff and trying to make that appropriate for a robot.
Right.
Anyway, thread lock. we're locking them so they can't compete. Well, we're not locking them so they can't compete, but yeah, we're locking them so they can't finish at the same time. So you could lock out resource and say, oh, you're getting to the resource, lock, you can't do, nobody else can access it until we're done. So threading.lock allows you to say, nobody else, no other threads can access this at that time. I don't know if that's what he does, but I mean, that's one way to do it. So that you can't have two people fighting for the same resource. Oh, and I think what I did next is I basically split it apart. Right? Because then I turned this into a library, I think. Yeah, I have a main and then I have that, and this is the library, so you can use it with anything else. So I did finally figure out how to do it. Let me find my little program. Let's see which one of these will work. I think this is the one. That's my antivirus heat setup. Looks like my antivirus saved it up. So concurrency. There's different ways to do threading. Concurrency is another module that does a lot of the same stuff. I was exploring at this point lots and lots of different ways to do threading. All right, I think this is my nice one. Oh, I don't have my rich module. Is that the only one I'm missing? Yep. I think so.